So you've got your 2D world ready. And the only thing left is to find the right technique to get it. But it isn't as easy as it seems. You can violently trace lines on your paper, but mathematically, you don't know shit about dividing a graph into regions. Don't worry, you're watching the right video. In this video, I will define a region as a part of your graph. Your job is to cut a graph into multiple regions. So first, let's go back where it all started, in the first dimension. In this world, a region is just a part of this line. In this case, a region can be defined as the open interval 1, 3, or just 1, 3 for short. Now you usually want to give your region a name. I will call mine A. So A is equal to 1, 3. Let's also create B as 3 infinity and C as negative infinity 1. In region A, we consider each number to be greater than 1 and less than 3. In region B, the numbers are greater than 3, and in region C, the numbers are less than 1. Do you see what I did there? I assign a condition for every region. I'll repeat it again because this is pretty important. Any number in region A respects the condition of being greater than 1 and less than 3. Every number in region B is greater than 3. Every number in C is less than 1. What I want to make clear is that a condition leads to a region. Now, in 2D, everything goes exactly the same. We can define region A as a part of the graph where every point x is greater than 3 and every point y is greater than 3. This forms a rectangle that extends to infinity. If infinity bothers you, you can create a region B, where each point x is included in negative 3, negative 1, and each point y is included in negative 3, 0. Each point in A has this specific property. The point x is greater than 3, and the point y is greater than 3. Knowing that, you can check if a point is in A just by verifying its coordinates. Now, the more complicated the condition is, the more interesting the region's shape will look. So to create something not as boring as a rectangle, you can take things to the next level. Let's consider the line y is equal to 3x plus 1. If you don't know why that is a line, I would love it if you can leave this video, learn what a linear equation is, and come back. To create a region, you can simply say y is less than 3x plus 1 or y is greater than 3x plus 1. That's the way to cut a graph just by using a line. You can use the line equation and replace the equal sign with the greater or less than sign. If you want to create circular regions, you will have to use distances in your conditions, because the entire definition of a circle is a set of all points that are at the same distance from a fixed point. The word distance literally appears in the circle definition. So, I will define region A as every point whose distance from the origin is less than 5. Using symbols that will look like this. Both definitions mean the same thing, and r squared represents the second dimension. If you want a region where every point isn't in that circle, you can try defining B as every point whose distance is greater than 5. You can also offset the region using the same formula by imputing another point besides the region. At this point, you know how to cut a shape with a line, you know how to define a rectangle, a circle. Now let me present you my favorite way of cutting a world, which is inputting a set of points and cutting the plane so that each point has its own region. This is called the Voronoi diagram, and the regions are called Voronoi regions. So I'll repeat it. You have a set of points and you want to assign each point a region. So point A1 has region A1, point B4 has region B4, etc. The points are called sites. So of course every point is a site. Again, site A1 has region A1, site B4 has region B4, and so on. George Voronoi came up with an intuitive way to cut a plane, where he assigned every point in the graph to the closest site's region. That doesn't make too much sense, does it? Well, alright, just measure the distance from this point to every side. The closest one is B, so the point is included in region B. So, region B is defined as the set of points where each point is closer to B than to any other side. The definition goes for every Voronoi region. Now, in the Voronoi diagram you might encounter some issues. There are points that are equidistant to side A and side B, so those points won't be included in either region. This isn't a video about Voronoi diagrams, so I want to go deeper now. I wish you luck in perfectly cutting your words, and see you next time.